Today I'm having a go at soldering up one of these baseboards. This particular version is for box 1, which is mostly about controlling the vehicle, like starting the engine, glow plugs, steering, throttles, stuff like that. I've split all the hydraulic actuator stuff into box 2, which has also got the cameras in it, which is quite nice. It just makes the box 1's less cluttered, a little bit easier to manage. So what have we got here? We've got some automotive relays here, and we've got some PCB holders here. I can hear screams of objection to this, so you can't use these PCB based relay holders for the current that goes through this relay. This relay is rated to 40 amps for the solenoid starter for the engine, and I think the glow plugs are about 20 amps. And if you use the PCB traces for connection to this connector here, they just melt. There's no way that that's ever going to work, but we have a quite a nice solution. We use this wire here and we manually create connections necessary across on the back of the PCB. That works really well. So that's our connectors for there. We've also got, apart from the 8 relays, we've got 8 high side switches. It's just a little bit of spare space on the board, and we've got some connectors here, which is quite nice. In addition to that, we've got a 5-volt regulator, which is supplying power to these 4-channel high-side switches. I call them high-side switches, but the manufacturer call them push-pull motor controllers. The L293, I think it's this, yeah, L293D, DIP mounted, so you can solder them by hand really easily. What else we've got? We've got an option here for having a current sensor system. I'm not going to put that in today. I've not actually found that I needed it so far, but there's an option there. So if you want to prevent some of the motors from burning out if they stall for some reason, like the steering for example, those could actually be quite handy in the future. We've got LED fuse box there. We've got a stack of Cytron dual channel motor controllers here. They can stack up quite high. Bus bars, some serious big bus bars, because we're using quite high currents on this board. And to start off, we'll put some solder down on these high side switches and this 5-volt relay. There are options here for LEDs for these 4-channel switches, but I'm not going to do that. It's kind of pointless really, because you're never going to see them other than if I wanted to test this board. But I've tested it before, I used it before, and never had a problem with it. There's also some capacitors here on the 5-volt power regulator. One large one and one small one, which are quite important. So let's put our stencil over it. It might be possible to do this without a stencil, but it's really nice just to get the correct amount of solder on these high side switches. And there is a really small capacitor there, so yeah, that would be quite difficult without a stencil. So line that up, put some tape on it, and start spreading some solder. So I'm going to try and solder these by hand. I could use a hot air gun, but my small hot air gun's broken at the moment, so I'm just going to use soldering irons. I've got a large soldering iron for doing the tabs on these high side switches, so I think it should be fine.
Toi qui n'as pas si fort, réveille-toi. ton frère, l'homme on s'aime. Je ne veux pas qu'autour de toi ça dégraine. Hey,
These are the heavy duty terminal blocks and our relay sockets. So if I turn this over now, you can see that there's no connections here between the power out of the relay through the connection block and the power in. So this would be something like the glow plug going to earth there. So live to earth on the glow plugs. And these connections here are the coil connections for the relay. So what we need to do to fix this is a nice little hack, which is to put some copper bus bar wire over through the contacts. So this PCB was laid out deliberately to do this. You just cut some nice heavy wire, lay them across, is coil of the wire, and solder them up. Just before I do that, if for some reason we need extra relays, there's an add-on board here, so we can add another 1, 2, 3, 4, 5, 6, 7, 8, 16 relays if we wanted to. I don't know why we'd ever need that, but you never know. If you've got some massive hydraulic solenoid valves that can't be operated by the high side switch, then that's a possibility. So let's go ahead and solder some of these wires up. This is where you really need this like 450 watt soldering iron. Here we have the base PCB pretty much assembled. We would plug in the relays at some stage and have these nice heavy Wago connectors for cables which would go to the starter motor and glow plugs. We have 8 high side switches for hydraulic solenoids or flashing beacons, that sort of thing. Ground connectors here, 12 volt, some smaller 5 volt, smaller ground one, and these are connectors to the 4-channel high side switches which control these relays. So you can't control the relays directly from the MCU, they have to go through this intermediary because the coils require too much current. We've got standoffs ready here for the next layer, which could be another layer of relays if we wanted to. We could put another, 16 relays there if we wanted to. But most commonly we'd want to put a layer of high side switches. A lot of agricultural vehicles have a lot of hydraulic solenoid valves, certainly mine does. So there's 20 channels of high side switches there for hydraulic solenoid valves. The standoffs, the size of the standoffs, the length is quite critical, because otherwise if they're too short then the MCU, because it's underslung, I'll just find that panel a minute. The MCU is underneath the next board, so to get plenty of clearance we need to have these standoffs at the right size. The minimum size is 45mm, not including the end of the standoff there, which is I think 6mm. These standoffs, to clear this 100 amp relay, they need to be 50mm. The M4, these are M3, these need to be, pretty sure it's 30mm to clear the capacitors. Yeah, that's 30mm. So these capacitors are quite tall. So these are M3 30mm. And then underneath at the bottom there's a M3 by 7mm, just to bring this board off the surface of this PCB here. We've got the bus bars there. The bus bars, unfortunately, they obscure some of the mounting holes. So when this PCB is inserted into the control panel itself, these bus bars have to be removed. And the best way to secure them is 4-pronged captive nuts, 4mm. And this board has actually got drill holes ready for the prongs of the captive nuts. So one thing I did this time around was I took out these terminal blocks here and spun them round so that the entry point is facing the inside of the board, which means it enables the high current motor connectors to come inside. It used to be the other way around, which was quite awkward, wiring these motors up. It did work, but it's not great. Although in the process of taking these out and reinserting them, it's quite easy to damage the board, so just be really gentle. It's quite tempting just to put too much pulling pressure on these terminals, and it breaks the top PCB trace, which is really thin. So just be really careful when disassembling this board. This one I got okay, but very sadly I've broken this one, and you probably can't see it, but I ripped off the top pads and the trace wires as well. So this is junk now, unfortunately, unless I try and solder a connection from the end of this resistor. So if you want to test it, just find the end of the resistor there, and then put another connection onto the top of these screw terminals. That'll check that you haven't damaged it. This one's fine, I've checked it. This one, that's junk. And that's about it. It's ready for some new layers now. So yeah, I'm gonna put the high side switch board here. I've got options here. We could put extra high side switch boards if we want to. These little PCBs can be swapped in and out and redesigned to whatever's required, really, because there is quite a bit of room there. There's also PCB in this format for current sensing, so that could be quite handy if you need to prevent the motors from burning out if they stall, which can happen on the steering. Yeah, so these little boards are quite useful there, and these motor controllers can be stacked up quite high. I'm not sure exactly how many there are. There's at least 4, which enables you to control 8 motors. So I think that's about it. We go to the next stage, which would be to insert this into the panel, just checking that everything's there, that all these standoffs are in place, because we can't go back and add more standoffs afterwards. It's pretty impossible. Just note that there's 6 standoffs on this section here, because when we come to operate these levers here, we definitely need the middle standoffs, otherwise the board tends to buckle inwards. But yeah, with these standoffs in this position, it's absolutely fine. So there we go, base PCB ready to be put into the control panel.